Coming to occurrence of carbon, as we know, carbon is existed under the earth crust. Under the earth crust, that is what 0.02 percentage on the atmosphere. It is present how much, guys? 0.03 percentage. Now, if we take here inside the earth crust, that is also, if you notice it, it is existed in form of combined state in the sense of like in the form of carbonates, understanding, in the form of carbonates, metal carbonates mixed with the metals, same way in the form of hydrogen carbonates means bicarbonates, coal and petroleum. Okay, coal is a pure form, coal and as well as petroleum, again it is a mixed form, and bicarbonates also. So bicarbonates means what, guys? Hydrogen carbonates. Understand, everybody? Please respond. So same way, if it comes to the atmosphere, it is existed only in the form of how much, guys? A combined state. It is how much? Carbon dioxide. Understanding? The what is the percentage, everybody? 0.03 percentage. So the percentage of carbon is very, very low in nature, but we are having an immense importance of carbon in our daily life. Now, if you notice it here, in this 0.02 percentage, it is existed in form of compounds like carbonates and bicarbonates, and also existed in the form of pure, that is what? Coal. So that is what, if any kind of substance is existed in like alone, then that is what we used to say free state. And if it is existed in combined with another substances, we used to call it as, what we used to say? Combined state. So carbon also coming to here, it will be existed in two states. One is carbon in free state. Do you understand, everybody? So carbon in free state means in the sense of carbon alone will be existed. So either in free state or in pure form, the carbon can exist. So that is only called as carbon in free state. So basically remember, carbon in free state or pure form is existed in only three forms. So that is only called as allotropes of carbon, which we are going to focus mainly on today's class. So that is only we used to call it as diamond. Next one is graphite, and the next one is what, guys? Buckminsterfullerene. Okay, Buckminsterfullerenes. Now, these are the three allotropes of carbon where a carbon is existed in free state. So remember, the percentage of carbon is very, very low in the nature, but these three pure forms of carbon all are existed. They are having a particular geometry shape. That is why these are called as crystalline structures of carbon. Do you understand, all of you? What is to call? Crystalline structures of carbon. So basically carbon can exist in two forms. One is crystalline form, another one is amorphous form. So amorphous form means no geometrical shape, geometrical shape means it is existed in a different form like a powder structure. So the example of amorphous form of carbon is, you can take coal. Is it okay, everybody? What is the example of amorphous form of carbon? Coal. And crystalline structure of carbon, which is having a particular geometry shape, is three. That is only called as diamond, graphite, and Buckminsterfullerene. So these three is called as crystalline allotropes of carbon. So that is what we used to say. These three are called as allotropes of carbon. So let us discuss what do you mean by allotropes. So these three are called as what, guys? Allotropes of carbon. So once again, I'm saying, remember, allotropy is a phenomena. So the same element is existed in two or more different physical form, but chemical properties is same. So like that substance is called as allotropy. If any substance is existed with the same chemical properties, but different physical properties, that is what we used to call as. What we used to call as?
Allotropes.
Called allotropes. Understanding? So allotropes always chemical formula is same, but the physical structure and physical properties are different. So that phenomena is only called as allotropy. So now if you take carbon crystalline allotropes are three. That is what? Diamond, graphite, and Buckminsterfullerenes. So these all are present in free state only. Means a carbon is present alone or it is present in the form of pure. So they are called as carbon in free state. Do you understand, everybody? So the allotropes of carbon, they will ask you, you should write crystalline allotropes of carbon. That is what? Diamond, graphite, and Buckminsterfullerene, which we will study in our today's class. So now, let us come to here. First, write all of you allotropes of, write definition of allotropy. You can take so many. Suppose phosphorus is present, red phosphorus, yellow phosphorus. So that is also called as allotropies of carbon. So same chemical formula, but different physical properties. That is what we used to call as allotropes. Okay. So be very careful with that. So now write allotropy. Allotropy. Right. The phenomenon of existence of the same element into two or more physical forms. Two or more physical forms is called allotropy. Full stop. The allotropes have same chemical properties, but different what, guys?
Physical property.
Different physical properties. That's all you have to remember. Clear, everybody? Samaya Mane is with you. Everybody, any doubt, please ask. Rajagavan, Vinod, Sarada, that is. So this is what carbon in free state we used to call as. So carbon in free state basically is existed in form of diamond, graphite, and Buckminsterfullerene. And also we can say like carbon. Carbon is the most form of free state of carbon is coal. Coal is the one which contains about most free state of carbon is coal only. So now carbon in combined state. So which we already knows, even we studied. So carbon in combined state present in both inside the earth crust and above the earth crust also. But the percentage is small, but you can notice it is present in a combined state, carbon in combined state. Combined state, if you notice. So basically, what is the compounds present in carbon? Anybody? Carbon existed in the form of what? Yes, please. Carbon. You also tell me what is the products of carbon? Compounds existed in the form of in the form of oxides. So what is the oxides of carbon? Anybody? Oxides of carbon.
Carbon dioxide.
Carbon monoxide and carbon dioxide. Next, in form of carbonates. Carbonates, tell me what is the formula? CO3 minus. Form of bicarbonates. What is the bicarbonates?
HCO3 1 minus.
HCO3. Understanding? Minus, correct, local? Next,
Sir.
organic compounds. What is the organic compounds? Organic compounds which will burn and will leaves you ash as well as carbon dioxide. What is that? Which will be under at the crust.
Methane.
Fossil.
Fossil fuels. Very good. Petroleum. The most important sources of compounds of carbon. Please remember. Most important source of compounds of carbon. Thousands of carbons will get from this, thousands of compounds of carbon from this only. So that is only called as hydrocarbons, which we are going to study from our tomorrow's class. That is what the real lesson of carbon and its compounds. Okay. So that is why hydrocarbons as the most popular one of this carbon combined state. So hydrocarbons, that is why also called as hydrides of carbon. Now itself learn hydrides of carbon. Hydrocarbons of carbon also called as hydrides of carbon. Okay. So this we all will study in the coming classes. So this is how the carbon is existed in two forms. One is combined state, another one is free state. Now if we take the free state, basically the allotropes of carbon which we have to study, that is what about diamond, graphite and Buckminsterfullerene. So these three which we used to call basically an allotrope. So now if you notice it in these allotropes, what will happen means the element of carbon occurs in different, basically as it is see that. So but this both diamond, graphite are formed by carbon atoms only. So then what is the difference between the diamond and graphite as it is fullerenes? So both are allotropes of carbon, but if you notice here, the difference lies in the manner in which the carbon atoms are bonded to one another. So that is the statement you should remember. Suppose I will ask you a question. Even though the diamond and graphite are allotropes of carbon, what is the difference? Even though they are having a chemical properties are same, what is the difference making their physical properties differs? The bonded, the carbon atoms, how they are bonded to one another is the only difference between diamond and graphite. Do you understand, everybody? So the difference lies in the manner in which the carbon atom are bonded to one another. How the carbon atoms are bonded is only the difference between the diamond and graphite. So if we take for example diamond, all of you observe in diamond each carbon is combined with 4 other carbons. Each carbon will combine with how many carbons, guys? Please respond. 4 other carbons. So like that they will combine together. Each carbon is having relation with the 4 different carbons. Like every carbon combined together and they will form finally a structure called as, basically is the structure is tetragonal structure, but this tetra and tetra finally combining like this and they'll form the structure like this. This is what we used to call as octagonal structure. Do you understand, everybody? So because of this octagonal structure only, if it comes to the physics, again there, the highest refractive index, Refractive index. Do you all remember that? All of you. Refractive
Sir.
diamond. How much it is? 2.42.
2.42.
2.42.
So because of the structure, this complicated structure, each carbon is combined with the four other carbons. So a four tetragonal combine and they will form. Always you might be noticed, diamond means the shape will be like this. Have you all noticed it? Yes or no? Please, all of you respond. So that is what the shape of the diamond basically we'll see in our market and all. So that is what octagonal structure will say. So which is having the highest density because of close packing of carbon atoms. Please remember, close packing of carbon atoms. The diamond is very, very hardest and as well as more density. Understand? And also see, because of this extraordinary brightness, because of this structure only, more and more internal reflections will take place. That is what we will say. The refractive index is extremely high. That is why the color, it is, if you take the color, basically the colorless diamond is more costliest diamond. If it is a pure diamond, the color of the diamond is what, guys? What is the color of the diamond?
Colorless.
Colorless. So that is what purest form of diamond we can say. So you can see even our India, you can see the most popular diamond which has been given to the British what we can say, okay, British kingdom. So you can see that what is the diamond name called as? Kohinoor diamond. So this Kohinoor diamond is the world's largest diamond, one of the largest diamond, which is around 186 carats. So that is the highest, like you can see the purest form of diamond, which is found near in Krishna River in our South India only. So that is the location of this Kohinoor diamond. So which is basically around 186 carats. So this diamond quality will measure in form of carat only. So 1 carat is equals to 200 milligrams. So please, this is also learned as it is a real life also we are having the importance of it. So this is what is a diamond. So if you take the only difference between a diamond and graphite is this one. So each carbon atom is bonded to how many carbons, guys, in diamond? Yes, please. How many carbons? Each carbon will be combined with the
4 carbon.
4 carbons. That is what tetragonal structure we can say. And tetragonal combined, it will form octagonal structure. So the carbon atoms are very closely packing. That is why it will form a rigid 3-dimensional structure. Is it okay, everybody? Please respond. A rigid 3-dimensional structure. And you remember, due to this, each carbon is combining with the 4 carbons. Do you tell me, is there any free valence? Is there any extra electron which is not combined? Each carbon, what is the valency? What is the valency of carbon?
4.
Tetravalency. So every carbon in diamond is combining with the other 4 carbons. So no free electron is present. So that is why a diamond is a bad conductor of electricity. Are you clear? And good conductor of heat. So that is what you have to remember. So that is why different physical properties, but same chemical properties. So it is a good conductor of heat, but an insulator or non-conductor of electricity. So what is the reason? Anybody? Because absence of free electrons. Each carbon is combining with how many carbons, guys? Diamond.
4 carbon.
4 other
4
carbons.
carbon.
So no free electron is present. That is why a carbon is always in form of diamond, it is a bad conductor of electricity and good conductor of heat. So all the bonds formed by this one, what kind of bonds, guys? Anybody can tell? What bonds they are? Ionic bonds or covalent bonds? Anybody? All the
Covalent
bonds
bond.
formed by diamond is covalent bonds only. So hope everybody understand. So that is what is diamond. So uses of diamond and all you are not having, you don't need to study anything also. Next. If it comes to the second one, that is what in graphite. So if you take in graphite, all of you, graphite, each carbon is made up of, each carbon is combined with another 3 carbons. Only 3 carbons having relation. So each carbon is having how many free electrons? Anybody? How many free electrons each carbon? Each carbon is combining with only 3 electrons. Now you tell me. So how many free electrons is there each carbon? All of you.
1 free electron.
Yeah, 1 electron. So
One free electron.
it here, every carbon is combining with only 3 electrons. You might be noticed. So whatever the carbon you have taken, always the each carbon, suppose this is a carbon I selected with the bond 1 and 2 and 3. So each carbon here only combine with the 3 electrons, so that each carbon having how many free electrons? All of you.
Free electron.
1 free electron.
Carbon has 1 free electron. So that is why you can notice it. The graphite is the best conductor of electricity. Do you all remember that? Please respond. So that is what it is. So the graphite is the one which has been combined a structure. Only 3, you can see that each carbon is bonded to 3 other carbon atoms in the same plane and giving the hexagonal structure. That is what we can say, hexagonal arrays. So if you observe the structure, so each carbon is combining with the 3 other carbons and it is giving what is the structure you can see. 1,